Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, refreshed and inspired. Also, please subscribe if my videos, lecture videos and sample problem videos are important to your studies. This problem was also solved using three-moment equations, and let's solve it by slope deflection equations so that the answers can be verified. By slope deflection equations, calculate the slopes at A and B and the moment reactions at D. E is 200 gigapascals, moment of inertia 200 times 10 to the 6 mm to the 4th. Support settlements A 20 mm, B 15 mm, and C 10 mm as shown in the figure. So moment at A, moment AB is negative 30 times 3. So it is negative 90 kilonewton meter. That's the overhang. So we set up moment equation for AB and BA because both ends have moments. And for the fixed moments, we have to consider strips. So EI of CD is 40,000 kilonewton meter square to just convert the product of 200 gigapascals and 200 times 10 to the 6 mm to the 14 kilonewton meter square, you'll get 40,000 kilonewton meter square. So therefore for AB, it is 40,000 times 1.5, 60,000 kilonewton meter square. For BC, 40,000 times 2, so it is 80,000 kilonewton meter square. So let's have that step. This is 20 dx, the differential force. Call this x. So therefore this distance is 6 minus x. Then for this triangular loading, uh, intensity of load, let's call that x. So this is 3 minus x. So intensity of load as to x equals 24 as to 3. Therefore the intensity of this loading is 8x dx, where 8 is 24 over 3. And the differential force is 8x dx. So negative 90 moment AB is 2EI over L, quantity 2 theta A plus theta B minus 3 times delta over L, where delta, because the chord joining A and B rotates counterclockwise, by the chord rotates counterclockwise and B is 5 mm higher than A in the settled position. So that's why the delta is treated negative 5 because the chord rotates counterclockwise. Remember the sign convention for slope deflection equation: clockwise positive, clockwise rotation positive. So that's why delta is negative 0.005 meter 5 mm over L, which is 8. And the moment of inertia of AB is 60,000, and we use 2EI over L because both ends have moments. Simplifying, by the way, plus fixed moment near, it is negative at A is in the left, so it is equal to the integral from 0 to 6 of 20 dx. A is 2 plus x, while B is 6 minus x, so quantity square over L square, 8 square. So negative integral 0 to 6 of 20 dx times quantity 2 plus x, 6 minus x square over 8 square. So simplifying, this value is 2 times 60,000 over 8 times positive 3 times 0.005 over 8, 28.125. This integral is negative 78.75. So simplifying, 30,000 theta A plus 15,000 theta B equals negative 39.375. Call that equation A. Then we set up moment BA. So moment BA equals, interchange the coefficient 15,000 plus 30,000 plus 28.125. Then for the fixed moment, positive integral, so we just make 2 plus x squared, 6 minus x raised to 1 over 8 squared, and positive 0 to 6, 20 dx, 2 plus x squared, 6 minus x over 8 squared. The value of this integral is 101.25. Therefore, MBA is 15,000 theta A plus 30,000 theta B plus 129.375. Call that equation 1. Then MBC, moment BC, both ends have moments, so 2EI, 2 times 80,000 over L, 5, quantity 2 theta B plus theta C minus 3 delta over L. Again, the chord joining BC is rotating counterclockwise, and C is 5 mm above B, so therefore 5 mm is treated negative 0.005 meter over L, which is 5, so that's the delta. So MBC equals 2 times 80,000 over 5, quantity 2 theta B plus theta C minus 3 times negative 0.005 over 5. Then fixed moment at B is negative integral of 8x dx. A is 2 plus x. Then B is 3 minus x, so quantity square over 5 square. So negative integral 0 to 3, 8x dx, 2 plus x, quantity 3 minus x square over 5 square. So the value of 2 times 80,000 over 5 times positive 3 times 0.005 over 5 is 96, while the value of this integral is negative 6.912. Simplifying, MBC is 64,000 theta B plus 32,000 theta C, then plus 89.088. Call that equation 2. Then MCB is 32,000 theta B plus 64,000 theta C plus 96, then plus integral, so we just copy this square 2 plus x, and 3 minus x raised to 1 over 5 square. So positive because C is right of B. C is at the right, so fixed moment is positive. So MCB, the value of the integral is 18.288. So simplifying, MCB equals 32,000 theta B plus 64,000 theta C, then plus 114.288. Call that equation 3. Then we proceed to MCD. MCD, again, D is the chord joining C and D is rotating counterclockwise. Again, delta is negative and it is 10 mm or negative 0.01 meter. So MCD is 2 EI. EI is 40,000 over L, which is 6. And quantity 2 theta C plus theta D, which is 0 because this is fixed. Then minus 3 times delta over L. Delta is negative 0.01 over 6. Fixed moment at C is negative. There are 2 loads, so negative 25 times 2 times 4 square over 6 square, and negative 30 times 4 times 2 square over 6 square. So the whole of this is negative. Simplifying MCD, this 2 times 40,000 over 6 times 3 times 0.01 over 6 is 200 over 3. The value of this combined is negative 320 over 9. So MCD is 80,000 over 3 theta C plus 280 over 9. Call that equation equation 4. Then MDC is 40,000 over 3, half of this coefficient, then plus 200 over 3, just like that. Then fixed moment would be plus positive at D. 20 times, we just copy this, then interchange the squared factor. 25 times 2 squared times 4 over 6 squared plus 30 times 4 squared times 2 over 6 squared. So the value of this is 340 over 9. Combining MDC is 40,000 over 3 theta C plus 940 over 9. Call that equation 5. Then we apply equilibrium at B. MBA plus MBC equals 0. And the equation that can be established would be simplifying 15,000 theta A plus 30,000 plus 64,000 theta B, so 94,000 theta B plus 32,000 theta C. Then transpose this to the right, so negative 129.375 and negative 89.088 is negative 218.463, equation B. Then equilibrium at C, MCB plus MCD equals 0. So the equation would be 32,000 theta B, then plus 64,000 plus 80,000 over 3 is 272,000 over 3 theta C. Then negative 114.288 and negative 280 over 9 combined is negative 145.399. So call that equation C. So solving equations A, B, and C simultaneously using your calculator. So theta A is negative 3.3214 times 10 to the negative 4 radians, so which is the same answer as that of the 3-moment equations. Theta B is negative 1.9607 times 10 to the negative 3 radians. Theta C is negative 9.1164 times 10 to the negative 4 radians. So that's it for this slide, and we'll continue by solving. So we have answered slope at A and B, and we will answer moment reaction at D. Moment reaction at D is the negative of moment DC. Take note of that. So let's continue. So remember, theta A is negative 3.321 times 10 to the negative 4 radians. Theta B, negative 1.9607 times 10 to the negative 3. And theta C, negative 9.1164 times 10 to the negative 4. So therefore, our answers would be theta A, negative 3, positive 3.3214 times 10 to the negative 4, because this is counterclockwise. And counterclockwise is positive. Theta B is also counterclockwise by slope deflection, but counterclockwise rotation is positive, so theta B is positive 1.9607 times 10 to the negative 3 radians. Then moment BC is 64,000 theta B plus 32,000 theta C plus 89.088. So MCD, that was the equation 4, and this is MDC, 40,000 over 3 theta C plus 940 over 9, which is equation 5. So MB is MBC equals 64,000 times theta B, negative 1.9607 times 10 to the negative 3 plus 32,000 times negative 9.1164 times 10 to the negative 4 plus 89.088, just to confirm moment at B with three moment equations. So MB is negative 65.569 kilonewton meter. From three moment equation, it was negative 65.571, so practically they are equal. MC is MCD, 80,000 over 3 times theta B plus 280 over 9, so it is 6.801 kilonewton meter, which is the same as that of three moment equation results. And MD is the negative of MDC, so negative of 40,000 over 3 times negative 9.1164 times 10 to the negative 4 plus 940 over 9. So MD is negative 92.289, which confirms our answer. So that's it for this problem.